Grade 7 learners. Welcome to another episode of Valenzuela Facebook Live. We are now in Lesson 4 of Quarter 3 and we are going to have an exciting and interesting day of learning science again. Are you ready? If yes, please click the heart reaction to start our exciting discussion. Great! Our most essential learning competency for today is to be able to infer that waves carry energy. And for our learning objectives, at the end of the lesson, you are expected to first, describe waves. Second, describe that waves carries energy using a rope or slinky. Third, identify and describe the different parts of a wave. Fourth, describe what happens to the particles of a medium as waves are propagated through the medium. And lastly, explain how wave motion transfers energy. As we proceed with our session, I want you to keep in mind these important reminders. First, prepare your pen, paper, and module with you to write down important details. Second, focus on the discussion. And lastly, post only the class-related question on the comment section. Let us start our discussion with a game. We are going to play decoding. All you need to do is to decode the hidden words using the emoji code box. Use the comment section to key in your answer. You have 15 seconds to decode each hidden word. Are you ready? Let us start. Here is the first hidden word. Your time starts now. You got it right! Mechanical wave. Let us proceed with our next hidden word. Your time begins now. Okay, time is up. The right answer is, you are so good, transverse wave. Here is the next hidden word. Your 15 seconds starts now. Fantastic! Longitudinal wave. Let us have the next hidden word. You can start now. What is your answer? Rest. You got it. How about this hidden word? Can you decode it? You may start now. The word being described is rough. You're doing great. Here is another hidden word. Your 15 seconds starts now. answer is compression, then you are correct. You did a great job, learners. You have perfectly decoded all the keywords. Mechanical wave, transverse wave, longitudinal wave, press, crop, rarefaction, and compression. Those are some important words that we will discuss today. From the previous discussion, you have learned about motion. You learned to create and interpret the visual representation of the motion of objects such as motion graphs. You also describe the motion made by an object and calculate the acceleration of a moving object. Today, our lesson is about waves. Did you know that waves are present in our daily lives? Yes, you heard it right. For today's session, we will explore the science behind waves. Do you have any idea what wave is? You can share your idea on the comment section. A wave is a periodic disturbance that moves away from a source and carries energy with it. Waves can transfer energy over distance without moving matter the entire distance. For example, an ocean wave can travel many kilometers without the water itself moving many kilometers. The water moves up and down, a motion known as a disturbance. It is the disturbance that travels in a wave, transferring energy. Then, what is a medium in relation to waves? A medium is the material through which a wave travels. Take note, the wave medium is not the wave, and it does not make the wave. It merely carries or transports the wave from its source to another location. The types of medium affects how quickly the wave can travel. Waves move through a medium such as solid, liquid, or gas in all directions from their source. A wave travels faster through a solid because the particles are more densely packed together. Are you familiar with the properties of waves? Here are the prime properties of a wave. We have wavelength, period, frequency, and amplitude. Wavelength of a wave is the distance between any successive identical parts of the wave. Next is period. Period of a wave is the time for particles to make one complete vibrational cycle. While frequency of a wave is the number of waves that passing a point in a certain time. The unit of frequency is hertz, which is equal to 1 wave per second. Last is amplitude. Amplitude of a wave is the maximum displacement of the particle from its rest point. Then, how about the types of waves? Specifically, there are two broad classes of waves. These are mechanical waves and electromagnetic waves. Electromagnetic waves do not require medium. Electromagnetic waves are waves that are created as a result of vibration between electric field and a magnetic field. In other words, electromagnetic waves are composed of oscillating magnetic and electric fields. It includes light waves, microwaves, infrared, X-rays, ultraviolet rays, and radio waves. However, the mechanical wave is a wave that is not capable of transmitting its energy through a vacuum. These waves requires a medium in order to transport their energy from one location to another. Mechanical waves can be either transverse or longitudinal waves. Do you have any idea what is a transverse wave and how does it work? Transverse wave is a wave that moves perpendicular to the direction of the wave motion. Here is a video showing transverse wave using a slinky coil. As you can observe in this video, the action of the hand causes a vertical or up and down disturbance in the slinky. The direction in which the wave travels is perpendicular to the direction of the vibration. Transverse means across or crosswise. The wave itself moves crosswise as compared with the vertical motion of the medium. Then, class, what is a transverse wave composed of? A transverse wave is composed of wave crest, wavelength, amplitude, wave height, and wave drop. Wave crest is the highest part of the wave. Next is wavelength, which is the distance between two consecutive wave crests or between two consecutive wave drops. Another one is the amplitude. This is the maximum displacement of the particle from its rest point. Then, the wave drop is the lowest part of a wave. Now, can you give me some example of a transverse wave? One of the examples is ripples in the surface of water. As you can see on the video, as the ripples move horizontally across the surface of the water particles vibrate up and down. Another example is the vibrations in a guitar string. As you can observe, the string is moving because it has just been plucked. Plucking the string gave it energy, which is moving through the string in mechanical wave. Seismic wave, particularly S-wave, is also an example of transverse wave. The disturbance that causes an earthquake sends transverse waves through underground rocks in all directions away from the disturbance. So class, my question is, what happens to the particles of medium as the transverse waves are propagated through the medium? One-dimensional transverse plane wave propagating from left to right, the particles do not move along with the wave. They simply oscillate up and down about their individual equilibrium positions as the wave passes by. And that is transverse wave. Now, let us proceed with the longitudinal waves. Can you share your idea about longitudinal waves and how does it work? Longitudinal wave is a wave that moves parallel to the direction of the wave motion. Here is another video showing longitudinal wave using a slinky coil. As you can observe on the video, as the slinky is stretched out in a horizontal direction and the first coils of the slinky vibrated horizontally. In such a case, each coil of the medium is set into vibrational motion in direction or in the direction parallel to the direction that the energy is transported. Then, what is a longitudinal wave composed of? Longitudinal wave is composed of wavelength, amplitude, rarefaction, and compression. Wavelength is the distance between two consecutive points in a longitudinal wave. Next is amplitude. It is the maximum displacement of the particle from its rest point. Another one is rarefaction. It is a region where the particles are furthest apart. And lastly, the compression. It is a region where the particles are closest together. Can you cite some examples of longitudinal wave? One of the examples is sound waves. As you can see, a speaker vibrates at a constant frequency and amplitude, producing vibrations in the surrounding air molecules. Another example is vibrating drum heads. As you can observe, the sound waves are generated because the drum head moves outward and inward, making air particles to move or vibrate in the same direction. Seismic wave, particularly P waves, is also example of longitudinal wave. A seismic wave or body wave that shakes the ground back and forth in the same direction and the opposite direction as the direction the wave is moving. Then, what happens to the particles of medium as longitudinal waves are propagated through the medium? One-dimensional longitudinal plane wave propagating down a tube. The particles do not move down the tube with the wave. They simply oscillate back and forth about their individual equilibrium positions. So class, do you have any idea how wave motion transfer energy? Let us learn how different waves transfer energy. Electromagnetic waves transfer energy through vibration of electric and magnetic fields. Sound waves transfer energy through vibration of air particles or particles of a solid through which sound travels. Water waves transfer energy through vibrations of water particles. Seismic wave usually generated by movements of the Earth's tectonic plates. Now, let us check if you learned from our discussion. Let us have a short quiz. Go to Science Quiz website by simply typing the link on your browser. So, https://docksters.com/science/quiz/waves_questions.php. Answer the 10 items question, then click the submit button to check if your answers are correct. Screenshot your score, then you can send it on your respective science teacher. And you can also post it on the comment section. You have 3 minutes to answer. So your time begins now. from one place to another? The choices are water, air, matter, energy, electrons. If your answer is energy, you got it right. Second question. What kind of waves vibrate our eardrums so we can hear? The choices are microwaves, water waves, light waves, sound waves, radio waves. The correct answer is right, sound waves. Third question. What kind of waves requires some sort of medium to travel through? The choices are mechanical waves, electromagnetic waves, all of the above, none of the above. If your answer is mechanical waves, you are correct. Fourth question. What kind of waves can travel through a vacuum? The choices are mechanical waves, electromagnetic waves, all of the above, none of the above. The correct answer is electromagnetic waves. Fifth question. What kind of waves transfers energy? The choices are mechanical waves, electromagnetic waves, all of the above, none of the above. The right answer is all of the above, because both mechanical waves and electromagnetic waves transfers energy. Question number 6. Which of the following waves is a mechanical wave? The choices are light, microwaves, radio waves, X-rays, sound. The correct answer is sound, because light waves, microwaves, and radio waves are all electromagnetic waves. Question number 7. Which of the following waves is an electromagnetic wave? The choices are water waves, seismic waves, wave in a spring, light, sound. If your answer is light, you are correct, because water waves, seismic waves, wave in a spring, and sound are examples of mechanical waves. Question number 8. In which of the following waves does the disturbance move in the same direction as the wave? The choices are transverse wave, longitudinal waves, all of the above, none of the above. The answer is longitudinal waves. Question number 9. In which of the following waves does the disturbance move in a perpendicular direction to the wave? The choices are transverse waves, longitudinal waves, all of the above, none of the above. The correct answer is transverse waves. For our last question, what type of wave is a sound wave? The choices are transverse and mechanical, transverse and electromagnetic, longitudinal and mechanical, longitudinal and electromagnetic. The right answer is longitudinal and mechanical. You can now screenshot your score and post on the comment section. Great job, grade 7 learners! I am proud the way you participated today. It seems like you really understood the discussion. And to summarize the discussion, always keep in mind these important details. from one place to another. Medium is the matter through which a wave travels. Examples are: sound you hear, the medium is air. Earthquakes, the medium is earth. Ripples in a pond, the medium is water. The properties of a wave are amplitude, wavelength, period, and frequency. Amplitude is the distance between origin and crest or trough. Wavelength is the distance between identical points on consecutive waves. Period is the time for a particle on a medium to make one complete vibrational cycle. Frequency is the number of waves that pass a point per unit time. Wave is classified into two broad classes of waves. These are the mechanical wave and electromagnetic wave. Electromagnetic waves do not require a medium. It includes light waves, microwaves, infrared, X-rays, ultraviolet rays, and radio waves. Mechanical wave thus require medium. Mechanical waves can be either transverse wave or longitudinal wave. Let us recall the difference between transverse wave and longitudinal waves. Transverse wave consists of crests and troughs, while longitudinal wave consists of compression and rarefaction. In transverse wave, the medium is moving perpendicular to the direction of wave, while in longitudinal wave, the medium is moving parallel to the direction of wave. Transverse wave can be propagated through solid and surfaces of liquids, while longitudinal wave can be propagated through solids, liquids, as well as through gases. Some examples of transverse wave are ripples on the surface of water, vibration in guitar string, seismic wave, particularly S waves, while the example of longitudinal wave are sound waves, vibrating drum heads, seismic wave, particularly P waves. Waves involve the transport of energy without the transport of matter. In conclusion, a wave can be described as a disturbance that travels through a medium, transporting energy from its source to another location without transporting matter. Wave propagation is any of the ways in which waves travel. With respect to the direction of the oscillation relative to the propagation direction, we can distinguish between longitudinal wave and transverse waves. Did you know, class, that waves affect our daily life? Why and how? Waves are everywhere around us. Radio waves carry information, while sound waves can carry conversation. And light waves stimulates the cell for vision. Electromagnetic waves can be used in medicine for imaging purposes, which allows doctors to explore what is happening inside a person's body without having a performed surgery. Microwaves and infrared waves can heat up food. So to deepen and widen your learnings regarding sound waves, your next live streaming teacher will discuss it further. I hope you learned a lot from our discussion for today. At this point, we will now proceed to our question and answer. I will give you 15 seconds to key in your question on the comment section. section. Your time begins now. Okay, so we got a question from a student in Bagbagi National High School. Ma'am, how can I create mechanical waves? So that is a good question. A mechanical wave is created by putting energy into it. You could do that, for example, by making a sound or throwing a stone into water to create ripples. Our next question came from a learner of Argong-Bato National High School. Ma'am, how do waves disappear? So waves disappear when particles of the medium stop vibrating. Example, you stop transfer of energy through a medium. The effect of this decrease in vibration can be seen in decrease of amplitude. And for our last question is from a student in Malanday National High School. Ma'am, what would happen if there were no waves? So without waves, energy cannot do anything. And without energy, waves wouldn't be able to create a disturbance or displacement. And so wouldn't be at all. These things that we call waves, therefore, are defining feature of our universe. So, thank you for those who asked questions. Other questions will be entertained by your teacher during your follow-up discussion. So, for your assignment, kindly answer the activities in your Quarter 3, Week 4 Science Learning Packet, Part 1, What I Learned. So it has been another very meaningful and interactive discussion. Thank you for participating and for watching Valenzuela Science Live Stream. Have a great day.